So today we will study about logic gates, and logic gates are the most important question for 12th class, and also for those students who study about computer science like computer. So there is also used logic gates. So the question is, what are logic gates? Logic gates क्या हैं? Explain the different type of gates and इसके कितने प्रकार होते हैं. So simply the first definition is what? A logic gate is an electronic circuit. What? Logic gates is electronic circuit. And second is, logic gates are devices used basic building blocks for the digital circuit. And third is, the logic gates used are like OR gate, AND gate, and NOT gate, NAND gate, and NOR, XOR, and etc. So these type of gates are used. So next, the gate is a digital circuit with one or more input, but only one output. The gate can be constructed from diode, transistor, and resistor. And when sometimes when you see any question like how can you build gates, so the answer will be with the help of diodes and transistors and resistors. So these are three. Okay. So logic gates. Here are the classification of logic gates. So basic logic gates. You have basic logic gates only three. So first is AND gate, OR gate, and NOT gate. And the second type is universal gates like NAND gate and NOR gate. I'll explain you all these topics in broad. Next, derived logic gates, and and you can say there is special gates. So what? XOR gate and XNOR gate. Okay, let's talk about this in broad. So here is our first AND gate. What is AND gate? It consists of two or more inputs and one output. You can see here in the image, here are two inputs A and B and one output, like you can consider this Z. So the output is highest is 1, because in binary 0 and 1 consist. So if and only if all the inputs to gate are high, okay. Output is low if at least one of the inputs is low, like 0. So what the reason? You can see it from here. The simple formula is output is equal to A dot B. In our AND gate, we use what? AND gate, if you give two inputs A and B, then it's multiply, like Z is equal to A dot B, simply. So you can see a truth table for this A and B. When you multiply 0 and 0, it's option 0. 1 and 0 is also 0. 0 and 1 is also 0. And 1 multiplied with 1 is equal to 1. So this is called our AND gate. Okay. Next, we have our OR gate. What is OR gate? An OR gate is a logic circuit with two or more inputs. It's simple thing. And the function of an OR gate can be expressed as if either of the two input or both are true. So these are theory. Let it go. And here the main thing we have to learn about this symbol, like how to represent this. So here is also same two inputs and one output, and let's consider this Z. So Z is equal to what? A plus B. Here we get the sum of inputs, and you can see this in the truth table. Here the first input is 0 and 0. When you add 0 and 0, what do you get? 1. When you add 1 0, you get 1. When you add 0 1, you get 1. And even you add 1 1, then in binary you get 0, but your remainder is 1, so that's why you can say here 1. Okay. Next, NOT gate. So NOT gate is basically a inverter, like the dash. If you put in put a input something like a, so you will get what? A dash, the inverse. Okay, so the truth table is this. When we input 0, then we get 1, and when we input 1, we get 0. 0 change 1, 1 change 0. Okay, so this is simple. Next, these are derived. So in NAND gate, you can see here N, A, and A, T. So the first letter you see N. So N belongs to not, N for not, A and D for or, A and D for and. So this is not and gate, mixture of not gate and gate. So these two gates, you can see here, this is our and gate, and this symbol represents what? Not gate. So this will be multiply and this will be invert. So you can see here in the formula, we input 0 and 0, it's multiply and we get what? 0. And 0, when we input it into not gate, then we get 0 to 0 is 1, and 1 multiply 0, we get 0, and still 0 change into 1 because of not gate. 0 and 1, it's also 0 and we get 1, and when we input 1 and 1, we get what? 1, but here will be 1 change into 0. Why? And you simply can say that this NAND gate is the inverse of AND gate because of not. So AND gate is basically inverse of AND gate. We get here what? 0 0 0 1 in what? In AND gate. But here is what? 1 1 and 0. So this is called NOT gate. Next, NOR gate. The NOR operation can be implemented with the combination of AND gate and a NOT gate, and like a inverter. Symbol of NOR gate. Here you can say A, B, and here are two inputs, and the output is Y. So NOR gate is what? It's basically N stands for NOT and OR stands for OR gate. And we can say that this NOR gate is the basically inverse of OR gate, because in the OR gate truth table we get what? We get here 0 1 1 1, and when we take inverse of this, invert this, then we get this. So simply here is the our symbol of what? NOR gate, and this is NOT gate. Not and or, and we say this what? NOR gate. Okay, next, XOR gate. These are a special type of gates. So XOR gate are very special gates. So XOR gate means what? It's mean XOR gate can have two or more than two inputs terminal and one output terminal. Okay, like this. Here we input A and B and we get the output Z. So in the truth table, what? When we input 0 and 0, we get what? 0. 1 0, we get 1. 0 1, we get 1. 1 1, we get 0. Because here gets the reminder list. 0 0 0 1 0 1 0 1 1 1 1 0, and reminder gets into here 1, and these all reminder is 0. Okay, so this is the thing. So this is like a operator. Okay, so this is our last gate, XNOR gate, and its mean exclusive NOR means not exclusive OR. So XNOR gate is equivalent to XOR gate. Okay, so symbol this A, there are two inputs A and B, and we get C, and here is the inverter. It changes the value 0 to 1, 1 to 0. Okay, so truth table for XNOR gate. So here basically our formula A operator B, and it will be the inverse of last gate. So 0 and 0 we get what? 0, but here will be 1, and 1 and 0 when we add, so get 1, but its invert is 0. 0 and 1 we get 1, but invert is 0, and 1 and 1 we get 0, but invert is 1. Okay, so these are 7 gates, and we have completed today. And we will provide these PDF notes on our channel. You can go and click and download these, and you can follow these pages also.